Hello and welcome to Tea Leaves Programming. Today we are gaming like it's 1979 and I am finished with EmuDevz. The game is done and you can see here we get as their final parting shot the instructions to draw the rest of the owl. The rest of the owl, in the case of not the Nintendo Entertainment System, is what is called the memory mappers or the mapper modules. And there are upwards of 200 of these, I believe. Many of them only used for one or two games. I went out of my way to implement MMC4 mapper number 10 because it's used for two of my favorite games, Fire Emblem and Famicom Wars. Let's actually show you this emulator. We are emulating not the Nintendo Entertainment System. So let's use one of the test games for this other system here. And we can see we have controls. We should have sounds. Let me make sure that that's turned up. Hopefully that's okay. Can I jump? I can jump. I don't actually know how to play this game. There are ways to debug them as they are going on. In fact, one of the later exercises requires you to cheat at a game. We can look at our CPU. You can see all the cycles running here. We can look at the PPU. Here's our mirrored screens. And we have information on our audio. So what do I think about EmuDevz? Well, this is an amazing achievement. And I want to be clear, the amazing achievement here is not creating an emulator, although that feels really cool. The amazing achievement here is putting this into a didactic framework that teaches people what's actually going on under the hood. I think that the developer made some amazingly smart choices about what to have I'm going to call them the player, what to have the player implement versus what to abstract away, and just some really smart choices, providing a library for byte manipulation. One of the implementation choices, one of the more complicated parts of the Nintendo emulator, is what's called the loopy registers, named after someone on a forum who reverse engineered how they worked. And the developer provided a library specifically for that. The loopy registers are part of the pixel processing unit. They provided a library to do that because the math there is very specific and very kind of weird. I love it. You should play it. But that's not really why I'm talking to you today. So all throughout this series of episodes, you heard me complaining about JavaScript. And JavaScript's an amazing language. The fact that we can write code like this and have it run in our browser and immediately see what's going on, it's really powerful. And I do think JavaScript is exactly the right choice for this type of game. The fact that I could bring up, the developer tools and actually look at what's going on. Oops, I left a debugging statement in there. The fact that I could bring up the developer tools and actually change things dynamically. Exactly the right choice. But I still don't like JavaScript as a language. And the reason I don't like it is it does not have enough type safety for my taste. And so it is with great embarrassment that I announce that the main effect of playing this game is it made me want to build a Nintendo emulator in Haskell. And in fact, I've started doing just that. So what does that mean, building an emulator in Haskell? Does it mean I'm going to be doing a series of videos walking through my building the emulator? No, absolutely not. This is a learning experience for me. I make my Haskell for Dilettantes videos, but let's be clear, they're called that for a reason. It's not a joke. I am a dilettante. This is probably the largest project in Haskell that I've ever attempted. Doing a larger project is kind of the point for me. If I'm doing it on video, if I'm thinking about talking to you, then that makes it harder for me to understand what it is that I'm actually doing. Maybe if I finish it, I will actually walk through and talk about the various design choices I made. Here you could see the types header where I've defined all the types. you know, I might do that at some point, but the interesting thing is just to note that I'm doing it and I'm loving it. And I want to call back, EmuDevz was a key part of that. What EmuDevz gave me, one was the motivation to want to do it, you know, better for some value of better, where that's just my personal bugaboo. But it specifically gave me a map. It gave me, okay, so you want to make an emulator, forgetting about the language, here are the parts you need. And here's the one order in which it makes sense to develop these parts and hook them up together. I have a reference. So when I'm looking at something like the PPU, I can look at the JavaScript code and actually use that as a reference. To give one specific example, instead of using a library for the loopy register, I actually implemented it as an integral part of the PPU. But having that loopy register library in JavaScript, I mean, it made implementing this much, much easier. So where am I now? Let's take a look. So far, as I showed you before, I have the basic types defined. I have been reading the cartridges and can access all the data. I've implemented about half of the memory map, and the PPU is about, I would say, half implemented at this point, and I have a series of tests to actually run it. I've also at this point, the CPU is implemented and then some. I've actually gone and implemented some of the more common undefined 6502 operations. In fact, let me turn on some of the debugging here. Right, this is running the infamous NES test cartridge. We don't do the reset vector here. We just start executing the cartridge at address C000. And you could see we are executing these instructions. We can see the registers, we can see how many cycles they take up, and this actually works. We get through about 5,200 of the NES test log, which is about where the undocumented instructions start showing up. It's actually a little past that. The CPU works well enough to run Nintendo games. I'm going to be using SDL for the graphics. I'm at the point where I can put up an SDL window and, you know, fill it with a color. I have not yet hooked up the PPU to our rendering surface, but that's coming soon, and I'm really looking forward to it. The other thing I've learned from this is that writing imperative or very imperative Haskell is extremely fun. It's a bit like operating in 1980s style BASIC, where, you know, you're storing everything in global variables, only instead of calling it global, you're using an environment. I have an environment here. Let me show you the types again. Right? We've got this top level type living in reader, which is basically this record here, and it holds references to everything. And we don't have to pass it around because it's in the reader. Anything that returns that type has kind of inherent access to it. Here's an example where I'm actually getting right here. And check interrupts, you could see these are actual IO refs that live inside that environment, and you could just say, give it to me, and then you have a reference to it. And then you could do whatever you want. The other thing I've learned is that there's this, when I've been doing my Haskell for Dilettantes problem sets, those problem sets tend to be either pure or imperative. And the thing I'm getting out of this project that I did not get out of the problem sets is this view of how those things are threaded together in practice, at least in a very synthetic, I'm emulating a CPU example like this. And you could see here, because we have multiple IO contexts, essentially, we've got the top level emulator context, and then these IO refs are technically in a different monadic context. We end up having to, litter the code with these lifts. Someone introduced me just last night to this idea, this library called data IORef lifted. And so in this code, in the PPU, I'm using essentially automatic lifting. And now I am suddenly able to just call read IORef without lifting things. It makes the code a lot cleaner. I love everything about the type safety. It has saved my bacon and guided my implementation so much compared to doing this in JavaScript. The only complaint I have, let me see if I could find an example here. This from integral call, if you're using the word 8 type to represent an 8-bit value, and you want to use that as an index in some API that requires an int as an index, you're using from integral all over the place. You know, it's fine. It's enforcing invariance, and it's making sure that you as the programmer understand what conversion you're asking for. It does get old a little fast. I bet if I did a word count of every keyword in this program and then sorted them by frequency, I would be willing to bet that from integral is number one with a bullet. So that's it. Very different video for me. I know I normally go into like painful detail about what exactly I'm doing, and you get to watch me struggle. No struggle today. This is a blast. I'm having so much fun. If you haven't played EmuDevz, here's the URL. You should go download it and play it. You can buy it on Steam. If you pay $10 for the supporter pack on Steam, you get theming support, sound effects, and the extremely important cowsay command. I paid for it. I want this guy to have money because I want more people to make crazy games like this. I have no financial incentive to promote the game. This isn't an ad. This is me telling you I played this and loved it, and it sparked me going off and working on an emulator in Haskell, and maybe it'll do something similar for you. I'm Peter B. The channel is Tea Leaves Programming. We're programming like it's 1979. Thanks for watching.